Thank you for watching this video. In this video, I'm going to be describing partial and joint variations. Let me explain partial variations by going straight into the examples. So in example 1, if we are measuring total weight, but the scenario is that you are carrying like some stones. So that is, there is your weight, which is always constant because your weight doesn't change. Then there's also the weight of stones that keeps increasing as we keep giving you more stones to hold. So you can see how this is a partial variation in the sense that if we were just to measure the amount of stones on a scale without you being involved, that would be a direct variation. So just the weight of stones is increasing as the number of stones increases. However, since in this case you are carrying those stones, so it's the weight of stones as they're increasing plus your weight, which is always constant. Joint variation, however, is different. As you can see in this example here, we have this A, which is directly proportional to both B and H. So what this simply means is that we have to multiply B and H with a factor because as B increases, A increases. Also, as H increases, A increases. So there's this sort of factor that can be multiplied to both B and H in order to find A, because both the increase of A and the increase of H lead to an increase of A. Or in other words, as B grows up, A grows up. As H grows up, A grows up. So we can find a K factor, which says that if we multiply that K by B and H, that means that as B and H are growing up, so does A grow up. So this is the sort of relationship that is described by joint variation. Let's take a look at this practice question. So I'll just go straight to working out this question. So here we're given this relationship T. T is directly proportional to R plus T, and then over R. So you can see with this R at the bottom, there's some sort of inverse relationship, but with this R plus R at the top, there's some sort of direct relationship. Let's just do the calculations and see what sort of relationship we get at the end. So we are told that if T is 10, then big R is 3, small r is 3. So I'll just plug those numbers into the equation. So here, this first equation that we are provided, and then these are the equation, same equation, but replaced with the actual numbers that we are given in this scenario. So now we are left with just calculating K, because from here, from writing T is directly proportional to this whole thing, we get to also to rewrite it here as we just multiply by K that entire thing. So what we're looking for is the K factor that multiplies this entire unit in order to get the T. So that's why we have the K. So from solving this stage, we get to find that our K is 5. So our relationship here is actually that T is equal to 5 multiplied by, in brackets, big R plus small r over big R. This is the relationship that we are able to derive from this question when we are given this relationship to begin with, and an example of the figures that started. Now we are told that now that you know that relationship, you should find the value of T when small r is 2 and big R is 4. Or that is simple. We just start with the relationship that we found, and we get to plug in the new values. Small r is 2 and then big R is 4. So you get to see that in that scenario, our T is actually 7.5. In this exercise, we are given that X is partly constant and partly varies in relation to Y. When X is equal to 40, Y is equal to 4. And when X is 42, Y is 7. So what we have to be able to do after learning partial fractions is to be able to interpret this sentence written in English and then translate it to actually writing the formula down in mathematics. So here we're told that X is partly constant. So because of this statement, X is partly constant, we know that X is equal to some constant plus, that is the partly constant one. So our constant here is, we're just going to call it C. And partly varies in relation to Y. So for writing our varies relation, this is we write alpha Y, and this simply means that X is proportional to Y, or X varies as Y varies. that is the second part. So this is alpha y. So x is partly constant and partly varies in relation to y. This is the statement. This is how we write down that as a formula. If you remember, in partial fractions we learned that this is the general formula for partial fractions. And from reading this question, I can see that it's a partial fraction because it says partly constant and partly varies. That's a partial fraction question. So now we are told that when x is 40, y is 4, and when x is 42, y is 7. Let us just take our formula that we found here and then put these numbers. So when we see x, we replace with the 40, and when we see y, we replace in the 4 in the first equation, and then in the second equation, we get to rewrite the formula, but replacing the x with 42 and the y with 7. So we get to derive these two equations. So this is what we get to have. And because now we've got, because we have provided this, the question says that we can be able to find x when y is equal to 30. So how are we able to find x when y is 30? Well, from deriving this formula, we have to actually be able to derive a general formula to know what this constant is and what this this varying constant is. This varying value is also, so that we can be able to generalize what x is when we are given a certain y. So what we are going to do is we're going to look for that constant and for that alpha from these two equations. And as you can see, this is some sort of simultaneous equation. So what we're going to do is to look for c and alpha using simultaneous equation. This is equation 1, this is equation 2. What I did here was to underline and then subtract. I subtracted equation 1 from equation 2. So this is 42 minus 40, we get 2. Then c minus c, that's 0, so we don't write the c down. And then 7 alpha minus 4 alpha, we get 3 alpha. So this can be rewritten as alpha is equal to 2/3. So we have found our alpha. Now that we have found our alpha, we put it back into, let's say, either equation 1 or equation 2. But in this case, I just chose equation 2 randomly. So c, we just put this alpha in here in equation 2. We have 42 is equal to c plus 2/3 multiplied by 7. And this is what we have here. So now I just find c by making c the subject of the formula by putting 7 that other side. So 42 minus 2/3 multiplied by 7, that gives us c is equal to 37 and 1/3. So now that we have found our alpha and we have found our c, we can generalize that x is equal to 37 and 37 in the third, which is our constant c, plus 2/3, which is our alpha, is plus 2/3 y. So this is the general formula. Whenever we are given a y, you know that we'll say this plus 2/3 of that y, then that's how we get our x anytime. So now let's go back to our question. Find x when y is 30. We'll start with our new relationship that we just found. So we'll start with that formula, and then all we have to do is to replace 30 into where y was supposed to be. So now it's easy to find x. So x is equal to, well, this here, 37 and a third plus 2/3 multiplied by 30. And we get to find that x is actually equal to 57 and a third. So that is the first answer for A. Now moving on to B, find y when x is 100. Again, we start from our initial relationship that we found here, that we derived here. So we start from there, and then we get to replace the x with 100. That's what we did here. Then we get to look for y by just doing this normal stuff. 37 goes other side. Now it's 100 minus 37 in the third. And then later on we get to multiply by 3/2, so that we get to find our y is equal to 94. So after you derive this formula, then it's simply in just the usual math that you're used to doing. Otherwise, the important things here to catch is that you have to be able to actually interpret English sentences to mathematical formulas, and then be able to derive the variables that are important. So we needed to find our c and our alpha to know the general formula for finding x when given y. Exercise number 3 is very similar to exercise number 2, so we'll just go right into it. Yeah, we're told that the cost of printing a newspaper is partly constant and also partly varies as the number printed. So that means when we see the partly constant and partly varies, we know that that is partial fractions, and we know that the general formula is going to look like this. y is equal to bx plus a. Okay, so now we're told that if the cost of printing 500 newspapers is 320, and then the cost of printing 1000 newspapers is 540, find the cost of printing 750 newspapers. So from knowing, okay, from reading the question, we derive that the general formula for partial variation is y is equal to ax plus b. And then also, since we know this formula already, we derived that if the cost of printing 500 newspapers, so in this case 500 is our a, or our alpha, and the 320 is our y, because the cost of printing is going to change with the number of newspapers. So that is why we would put 500 next to the x. So like if the number of newspapers printed increases, that means that the cost is actually going to increase. So we would put 500 next to the x. And that's also what we did with the 1000 newspapers. Here we said 540 is equal to 1000x plus b, because again, partly varies as the number printed. So the number printed is the number of newspapers. That's why you put the 1000 here, and we don't put the 540 here. I hope you understand that. Okay, so now that you can see that we have written these, we've derived these two equations, or simultaneous equations, from just the numbers that we are given to begin with. You can see that we need to look for x and we need to look for b. B is our constant and x is the varying constant. So now we'll use simultaneous equation in order to get our x and our b, so that after getting the x and the b, we can be able to write a general formula that can be used for this problem all the time. So yeah, with the partial fractions, what we're going to do is just to say, well, 540, or okay, equation 2 minus equation 1. So 540 minus 320, we get 220. Then 1000 minus 500, we get 500. Because of that, you can just see that 220 is equal to 500x. So x is equal to 220 over 550. X is equal to 2/5. So now that we've got our x, we can put our x either in equation 1 or in equation 2. Here I just randomly chose equation 1. So we've got 320 is equal to 500 multiplied by the new 2/5 that we found plus b. So we can see that b is equal to 320 minus 200, which is equal to 120. So you can see now we found our x and we found our b. Now we can write our general formula as y is equal to 2/5 times x, and then plus 120, 120 being the constant, 2/5 being the factor that changes x all the time. So now our question is actually find the cost of printing 750 newspapers. Since 750 newspapers is a number, we put here 750 next to our what used to be x, which is the 2/5. So y is equal to 750 multiplied by 2/5 plus 120, and we get to see that the cost of printing 750 newspapers is actually 420. So again, the important things here is to be able to translate translate this story problem or story question into actual formulas. So since you can see partly constant, partly varies, that's partial fractions, which is ax plus b. And also you have to understand which one is the a and which one is the y. So in this case, the cost of printing was the y and the number of newspapers was the a.